Welcome to rotations. This time we're going to be rotating around the point that is off the object. So we have our object just below here, and we have our rotation point indicated that is 2 squares above the object. So it's not attached to it, but away from it. Now, we could still make a rotation. The analogy that I always like to make is tetherball. Think of your rotation point as the pole that's stuck into the ground, and your object is the ball. Now the difference is you need a string. So if you remember tetherball, there's a ball, it's attached to a string, it's attached to a pole, and you have to hit the ball around this pole and try and get it as close and high as possible. Now this is exactly what's going to be happening. So you have your object, which is the ball, and you have your rotation point. Now we have to create imaginary string for this rotation. So we're going to align our rotation point with the closest point to our object. So we're going to pretend that this is a string and it is attached to our object, and it is going to rotate around this point. So it always has to be an equal distance away from the rotation point. So in this case it is 2 squares. So to make a turn counterclockwise, our object is going to have to go this way. Okay, so we're only going to be going a quarter turn. Now, a quarter turn is the same as a 90-degree angle. So the first thing that we need to do is we need to create a 90-degree angle with our rotation point. So we have it going down vertically over here. So we know that when we rotate it, it is now going to be over here. We create our 90-degree angle. And the key here is you have to have the equal distance, the same as before. So it's 2 squares. So therefore I made my next rotation here. It's going to be 2 squares as a horizontal line. Now, the ball on our tether ball is always attached in the same spot. It doesn't really move around. So we have to think of that as the same thing on this object. So our string is attached to the corner of the object right over here. So if it is attached over here, when we make our rotation around, it's going to be in the same spot right there. However, remember that when you rotate, and I'm going to show you using the computer here, that when you rotate an object, things will turn like this around in a counterclockwise motion. So the back part is always going to be the same. So in order to have this object end up on the other side, we cannot keep it like this, because the back part of our object, back over here, has to be facing always on the outside. So when we rotate this object around, we have to keep the point still attached, but that back part has to be on the outside. So we rotate it around like this, and our final position, we have to keep the corner attached because it's a string, and our quarter turn is going to look like this. So know where what the distance is between the rotation point and your object. If you're asked for a quarter turn, make a 90-degree angle. Remember where the ball is attached to the screen. So in this case, they are still attached at the corner of this object. And remember that when you rotate objects, the inside is always going to be closest to the inside, and the outside of the object is always going to be on the outside.